All right, Unit 5 test review. So let's get it. All right, simplify the expression when adding. So when you're adding, as long as you notice it's a plus, we know we're adding. So the parentheses we could just drop, and all you're doing is combining the like terms. 5 plus 3 is 8. 2 plus negative 7. Negative 5i. B. 9 plus negative 7. 2. 4 plus negative I. Or negative 11i rather. 4i plus negative 11i is going to be negative 7i. And then C. 5 plus 5, 10. Negative 8 plus 7, negative 1i. Okay, subtracting. Just as easy. The only difference is we're subtracting now. So you can either subtract the terms or you could distribute the negative. Either way, it's going to work out the same. So this is going to be, so if you distribute, then you add, right? So this is going to be negative 3, positive 9i. And now we're just combining like terms, right? 5 minus 3. 5 minus 3 is 2. 4 plus 9, 13i. B, distribute the negative. So negative times negative is a positive 3. Negative times a negative is positive 6i. And now we just combine like terms. 8 plus 3, 11. 10 plus 6, 16i. All right, C. We have negative 3, negative 8i. Combining like terms. 7 minus 3, 4. 6 minus 8, negative 2i. Okay. Simplifying the expression by multiplying. So here, we're going to do FOIL, right? First outer, inner last. That's the acronym we use. And remember, when you're multiplying variables, you add the exponents. The exponents go up by 1. So this is 2 times a. So this is 2a squared. Outer, negative 12. A times I is just ai. 5i times a, positive 5, again, ai. And then last, 5 times negative 6 is negative 30. I times I is I squared. So when you combine these, the things that are alike, right? So 2a squared, that's the only a squared term. And we have two ai terms, negative 12 plus 5, negative 7 ai. And then lastly, I squared is really negative 1. So negative 30 times negative 1. All the negative 1 does, or the I squared does rather, it changes this to a positive, the sign in front of the number. So this is going to be plus 30. And that's it. Let's try it again. So B, x times 6x. This is 6x squared. X times 2i plus 2xi. Enter. Negative 30 xi. And then last, negative 10i squared. Combining the like terms in the middle. 6x squared minus 28 xi. And then I squared is negative 1. It's going to change the negative to a positive. So positive 10. Not bad, right? All right, C. First, 6v times v. 6v squared. Outer, negative 6vi inner, negative 9 VI, and then last, negative times negative is a positive 9I squared. So combining the like terms, we get 6V squared minus 15 VI, and then I squared is negative 1. So this is negative 9. All right, moving along, number 4. A. So we're simplifying. So this is where we break down the number inside the square root into its prime factors using the little tree method. So you could use whatever numbers you want as long as it's 2, 3, 5, 7, and so on. I just start with 2 because it's an even number. Right, this is an even number. So this would be 75. We could use 3, 3 and 25. 25 is 5 and 5. Now, you always got to take out the pairs, right? All these numbers are underneath the square root. If it's a pair, it could leave the square root as a single number. So this is going to be 5. And then the 2 and the 3 stay inside the square root and they get multiplied. 2 times 3 is 6. So if it's a pair, it can leave, be removed from the square root as a single number and be multiplied by whatever's in front if something is in front. And if it doesn't have a pair, it stays inside the square root and gets multiplied. B. Again, an even number. So 2 and 60. 2 and 30. 30 is 2 and 15. 15 is 3 and 5. So here we have a pair. That's going to come out as a single 2 and get multiplied against the 5 outside. So negative 10, right, because 2 times 5. And then all the singles stay inside the square root and get multiplied. 2 times 3 is 6. 6 times 5 is 30. All right, C. Here, this one's a little different. The only difference is that there's a negative underneath. So I know that that's going to come out as an I. And then we just continue on as normal. 2 and 40. 2 and 20. 2 and 10. 2 and 5. There's a negative 4 out front. So anything we take out is going to get multiplied. So this is going to be 2 times 4. And another set of 2s, a pair of 2s, that's going to come out. So outside we have 4 times 2 times 2, which is negative 16. And then the 5 is single, stays inside, and we can't forget about the I. The I was already out. Right, you always want to take out I out first. That's the first thing you're going to take out. Okay, solve using the square root method. So we'll do each of these. We use the square root method when it's only x squared. Right here we have x squared only. That's the only variable. So we're going to isolate the x squared to get it by itself. So we have to start moving things around in the equation. So this is 4x squared equals 25. Divide both sides by 4 because we're trying to isolate x squared. 25 is not divisible by 4. So x squared is equal to just 25 over 4. Now, to get x squared by itself, to get rid of the square, we have to take a square root. That's the only way to get rid of the square. Do it to both sides, not forgetting about plus or minus. So here we have x is equal to plus or minus. Now, it's a fraction inside of a square root. So we take the square root of the top, square root of the bottom. Square root of the top is 5. Square root of the bottom is 4. No, it's not. It's 2. Square root of 4 is 2. Okay. B. Same idea. Get x squared by itself. So I'm adding 98 to both sides. So 98 is equal to 2 x squared. Divide both sides by 2. This is going to be 46. 98 divided by 2 is 46. This is equal to x squared. All right, to get x by itself, we have to take a square root of both sides, not forgetting about plus or minus. So I'm going to rearrange this a little bit. So x is equal to plus or minus square root of 46. 46 is not a perfect square, right? Nothing comes to mind. However, we can simplify this by using the little tree method. So this is going to be 2, 23. 23 is a prime number, so it can't go anymore, right? There's no pairs. So this is just our answer. Okay, C. Here, it's a little bit more involved, but it's okay. Still, same idea. There's only one x, and it's potentially squared. So we're going to start by moving the 64 by subtracting 64 from both sides. So negative 64 equal to negative 4 x minus 5 square. Okay, here you can't, I don't say you can't. I wouldn't suggest taking the square root first. Always try to start outside of the parentheses, right? Because it's just better. So 64 divided by 4. Negative divided by negative is a positive. So it's going to be 16 equals x minus 5 square. Now we take a square root. So we have plus or minus, the square root of 16. That's a perfect square. So 4 equal to x minus 5. All right, we're almost there. We have to isolate x, get x by itself. So we add 5 to both sides. So notice this is plus or minus, right? There's two values here. So the positive 4 plus 5 is going to be 4 plus 5, which is 9. And then the negative one, negative 4 plus 5, which is 1. So those are our two answers here. All right, positive 4 plus 5, negative 4 plus 5. Okay, last one for this section. I'm going to subtract 27 from both sides. So we have negative 3 x minus 5 squared equals negative 27. I'm going to divide both sides by negative 3. So this is going to be x minus 5 squared is equal to negative divided by negative is a positive. 27 divided by 3 is 9. So taking a square root of both sides, we get x minus 5 is equal to plus or minus square root of 9. That's a perfect square, so 3. Isolating x, plus 5 plus 5. Again, we have two values, positive 3 plus 5, negative 3 plus 5. So x is equal to positive 3 plus 5, which is 8, or x is equal to negative 3 plus 5, which is 2. Okay, number 6. We're going to use number 6 to figure out A, B, and C. Okay. Two things. We need to figure out, 3 things actually. We need to figure out the discriminant. The discriminant's easy. That's just the part under the square root. Whatever the number is under the square root, that's what it's going to be. And then what types of solutions, depending on what the discriminant is. And then the actual solutions, or the actual roots or solutions rather. Okay, so let's just start. Quadratic formula is posted right there. So A, B, and C. Notice B is -4, right? It's -4. That's not to be confused with the negative that's in the quadratic formula, right? If you're going to make a mistake, that's where it's going to be. So -4 plus or minus, right? Two answers typically. All right, we have B squared, so -4 squared minus 4 times A, which is 3, C, which is 2. So pause for a second, because the discriminant is this part underneath. So let's simplify. Well, getting a little ahead of myself. All over 2 times A. A is going to be 3. Okay, so the discriminant is the part underneath the square root. So we're going to have to simplify that first. So let's just start simplifying. So negative times a negative is a positive. So +4 plus or minus. Okay, -4 squared is 16. Minus 4 times 3 times 2, 24. All over 2 times 3, which is 6. All right. 16 minus 24. This is going to be -8. So the discriminant is -8. Okay, so look, we have 4 plus or minus square root of -8 all over 6. So this is what we have to simplify. So first off, the discriminant is negative. This means we're going to have 2 imaginary number. Two imaginary roots. That's what we're going to have. Because there's a negative under the square root. Right? That's what the discriminant tells us. Meaning I is going to be in our answer. So I know I is going to be in the answer. I can see that because there's a negative under the square root. So we get 4 plus or minus √8i over 6. Okay, this is pretty much the answer. This is pretty much the roots. However, you have to simplify √8. Right, square root of 8 simplifies to 2 and 4, 2 and 2. So a pair is going to come out. This 2 will stay inside. So we get 4 plus or minus 2√2i over 6. And then the last step is simplify if all 3 terms can be simplified, right? The GCF, greatest common factor. So you could reduce these by 2. So this would be 2. This is a 1. This would be a 3. So the roots in the final answer. X equals 2 plus or minus √2i over 3. I know it's a lot, but that's where we want to be, right? So we have a couple more examples where we do this. Okay, B. So notice there's an equal sign. So the hint, we want to rewrite it because this number needs to be on the left-hand side. So I'm going to add 5 to both sides. So this is x squared minus 4x plus 5 equals 0. Now we can apply the quadratic formula, A, B, and C. Again, B is -4. So this is going to be -4 plus or minus -4 squared minus 4 times A, which is 1, times C, which is 5. All over 2A. A is just 1. Okay, simplifying. Negative and negative is a positive. So we have 4 plus or minus 16, because 4 times 4, minus 20. All over 2. Okay, the discriminant, the part under the square root, 16 minus 20 is -4. So that's the discriminant, -4, right? The part underneath the square root. Because it's negative, we're going to have 2 imaginary roots. 2 imaginary roots. I is going to be in our answer, basically. Okay, we have 4 plus or minus the square root of -4 over 2. 4 can be simplified, and the negative comes out as an I. Right? So that's going to come out as an I. So this is equal to 4 plus or minus the square root of 4 is 2, I over 2. Then all 3 terms can be simplified. Well, I can factor out a 2 from everything. So this is going to be 2. This is going to be a 1. This is going to be a 1. So our answer, final answer, 2 plus or minus 1, so I don't even write it, I. And then over 1, I don't write that either. We don't write over 1, and we don't typically put 1 in front of variables. So those are our solutions, our roots, x plus or minus 2i. I have to watch that a couple times. Listen to the reasoning there. Okay, C, last one for this section. So again, I need everything to the left. So plus 16, plus 16. So this is x squared minus 8x plus 16 equals 0. Now we can apply the quadratic formula, a, b, and c terms. B is -8, so minus -8 plus or minus -8 squared minus 4 times a times c, all over 2a. So this is going to be 8, because negative times a negative, plus or minus 8 times 8 is 64, minus 4 times 16 is also 64. That's nice. Over 2. So the discriminant, the part underneath, is going to be equal to 0. So the discriminant is 0. When the discriminant is 0, we're guaranteed to have one solution. So what is that solution? Let's see. We have 8 plus or minus the square root of 0, which is 0, over 2. So 0, so just 8 over 2, which is 4. So x is equal to 4 is our solution. We only have one root, one solution. Okay. Now we're talking about analyzing the discriminants. Okay, so we have a discriminant for number 7. -3 squared minus 4 times 2 times 2. So -3 squared is 9. Minus 2 times 2 is 4. 4 times 4 is 16. So this is going to be -7. Since the discriminant is negative, we're going to have two imaginary solutions, right? You'll only ever have one real, two real, or two imaginary solutions, right? There's no such thing as one real and one imaginary, right? One imaginary numbers always come in pairs, so it has to be 2. All right, let's look at number 8. 8's the same way. I can go ahead and cancel out C, right? There's no such thing as one real and one imaginary solution in the context of what we're talking about. So 8 times 8 is 64 minus 4 times 8 times 2. So 8 times 2 is 16. 16 times 4 is 64. That's what we just had earlier. 64 minus 64 is 0. So the discriminant is 0. That means we're going to have one real solution if the discriminant is 0. All right, what is true about the number and type of solutions for the equation x squared plus 8x equals 14? So basically, we just need to figure out what the discriminant is. So this is going to be negative 14, negative 14. So I'm moving it over. So it's going to be negative. So A, B, and C. C is negative 14. So the discriminant is going to be 8 squared minus 4 times A times C. Okay, this is 64 plus whatever, right, because negative times negative is a plus. 4 times 14. So this is going to be 4 times 4 is 16. Carry the 1, 56. So this is going to be 120. A positive number. I don't care what the number is. I care is it positive, 0, or negative. It's a positive number. So that means we're going to have two real solutions because it's positive. Right, because it's positive. Here we had 0. That's one solution. And then here it was negative. Two imaginary solutions. Okay, let's review on factoring number 10 and then solve. All right, so we're going to factor this using whatever method we want. I mean, really, we could hit it with the quadratic formula and come up with the solutions, but let's just factor it. So remember factoring? A times C, which is 15, and we want to see what adds up to B. So two numbers that multiply to make 15 that add up to negative 8. So because we need to add it to a negative number, they have to be negative. And not only that, this multiplies to make a positive number. So negative 3, negative 5, right there, that's it. Negative 3 and negative 5. So the factors are going to be x minus 3, x minus 5. The solutions inside lies. X equals positive 3, opposite. X equals positive 5, again, opposite. So there are the factors, and there are the roots. All right, let's try another one. Okay, this one's a little bit more involved because A, B, and C. A is different from 1. A is not 1. So now, this is the slide and divide method, right? Here's the slide part. So 2 times 6. That rewrites the problem into 6 times 2, which is 12. Right, times. Then we'll have to divide it out here later. So now, again with the x method, 12, 7. So numbers that multiply to make 12 that add up to 7. 1 and 12, 2 and 6, 3 and 4. 3 and 4 add up to make 7. So put it in the factor form. This is going to be x plus 3, x plus 4. Now, here comes the divide part, right? This is the most forgotten about part in the process. Because we times by 2, here we have to divide by 2. So this is how you do that. Slide and divide, right? This is the method. Okay, You reduce when possible. So this is going to make x plus 2, right? Because 4 divided by 2. Now, 3 does not divide by 2. So when it doesn't divide, you move the number up. So this is 2x plus 3. So these are the factors. These are the factors. The roots or solutions are the opposite here. So this was going to be x equals negative 3 over 2 and x equals negative 2 because 4 divided by 2. So you might have to watch that a couple of times as well, or follow along in the next one. But when a is different from 1 and you have to do the slide and divide method, just understand what are the factors and what are the roots, right? So that's going to be the big one. Okay, C. 3, 21, 36. Right away, I realized that each 3 terms can be divided by 3. So I'm going to factor out a 3. So 3 is one of the factors right away. We have x squared left over minus 7x plus 12. Negative 7 plus 12. Why does it sound familiar? Oh, it's because of what we just had right now. Okay, so factoring this, 2 numbers that multiply to make 12 that add up to negative 7. Well, 3 and 4. 3 and 4 make a 7 when you add them, and then 3 and 4 multiplies to make a 12. However, it needs to be negative. So both of them need to be negative. So we take these numbers, right, and drop them into a set of parentheses. X minus 3, x minus 4. And you can't forget about the 3 that's outside. Okay, so these are the factors. Now, the roots are going to be opposite, right? X equals 3 and x equals 4. Now, notice we didn't have to divide anything out, right? Because we didn't do the slide and divide method, even though it kind of looks like we did. Over here, we multiplied the 2 times the 6 first to get a new quadratic. Here, we're factoring out a 3. It's completely different. I'm taking a 3 out. I'm not moving the 3 over. So 3 is definitely a factor. And then when in terms of the roots, the outside number has no control over the roots, right? It's just the inside parts, opposite of the inside parts. So there's that. All right. Second page. Okay. Simplifying radicals. So here's the thing. No radicals in the denominator. The bottom, right? No radicals on the bottom. So the way we do this, we have to multiply top and bottom by whatever is in the bottom. And then we multiply straight across. So top, remember when you're multiplying square roots, outside times outside. So 2, that's the only thing that's outside. And then inside times inside. 15 times 3, which is 45. Here, 3 times 3 is 9. Square root of 9 is just 3. So what we say is that if the inside of the square roots match and you're multiplying, the answer is just the inside part, right? Because square root of 9 is 3. Now, you always have to simplify with square roots. That's the annoying part, right? So we have to figure out what the square root of 45 simplifies to. So this is going to be 5 times 9, and this is going to be 3 times 3. So a 3 is going to come outside of the square root, and 5 will stay behind. So there's already a 2 outside. So 2 times 3 is 6. Root 5 is inside. 3 is underneath. And now you have to see if the fraction simplifies, which it does. Right, 6 and 3. This will just make 2. So the answer, final answer, 2 root 5. Okay. Moving along. Hopefully you can see what's happening here. All right, B. Here we have a fraction, 7 over 5, all inside of a square root. So I would rewrite this, root 7 over root 5. Multiply it by what's in the bottom. So root 5 over root 5. Multiply straight across. Root 5 times root 5 is just 5. 7 times 5 is 35. 35 can't be reduced anymore because it breaks down into 7 and 5, right? 7 and 5, and there's no pairs. So that's it. It's nice when that happens. All right, C. Same thing. Same thing. Rewriting this as root 6 over root 11. Multiplying by root 11. This is going to be root 66 on top, right? 6 times 11 is 66. That can't be broken down anymore. And then 11 on the bottom. Okay. That's it. I mean, it looks harder than what it is, right? Okay. Simplifying. We're subtracting square roots. The only way this works is if the square roots match. And right now they don't. One's root 24, one's root 54. So we have to simplify each until they do match. So 2 and 12, 2 and 6, 2 and 3. The pair is going to come out as a single 2 and multiply against the 3. So 2 times 3 is 6. 2 and 3 are left on the side. So this is going to be 2 times 3, which is 6. So 6 root 6. That's the first part. Second part. 2 and 27. 3 and 9. 3 and 3. So here we have a pair of 3s. That's going to come out as a single 3. So 3 times negative 4, negative 12. The 2 and 3 are left over. So root 6. So here, they do match. So we can combine these. 6 minus 12. 6 minus 12 is negative 6 root 6. Right? Treat it like a label. All it is just a label at this point. Right? 6 root 6 minus 12 root 6 is negative 6 root 6. Okay. B. We have to simplify the square roots. Can't simplify 2 anymore, but we can do 8. 2 and 4, 2 and 2. Pair of 2s, that's going to come out and multiply against the 3. So we're going to have 6 root 2 minus 2 times 3, which is 6. And then look, root 2 is left inside. So we have 6 root 2 minus 6 root 2. Well, if I have 1 and I take it away, we get 0. That one's easy. Again, that's only possible when the square roots match. All right. C. we have 18. This can be broken down into 2 and 9. 9 is 3 and 3. There's a pair of 3s that's going to come out. So 3 root 2 plus 4 root 2, right? We can't do anything else. Those are going to combine. Those are going to combine. What do they combine into? 7 root 2. We'll do that in a minute. So 50 and is 2 and 25. 25 is 5 and 5. Again, the pair is going to come out. 2 is left inside. So minus 5 root 2. Combining what we know, 3 plus 4 minus 5. Well, a little easy. 3 and 4 is 2. 3 and 4 is 7. 7 minus 5 is going to be 2 root 2. Is that it for the page? Nope. We have one more. Okay, here we go. Simplifying all the way. All right, so here, look what's different. In the denominator, it's not just the square root. It's the square root plus some other stuff, like plus a number. So what we have to use is called the conjugate. All the conjugate is it's a changing of the sign, right? Because in the previous examples, or a few examples ago, when you have a square root in the bottom, you multiply top and bottom by whatever is in the denominator. Here, what's in the denominator? 4 minus 3. 4 minus root 3. So I'm not going to use 4 minus root 3. Instead, I'm going to use 4 plus root 3 because it's the opposite sign. Because that's what a conjugate pair is, right? It's a number and a square root. 1 minus, 1 positive. Top and bottom. It has to be opposite. Otherwise we can't do the calculation we're about to do. Okay. Distributing up top, 5 times 4 is 20. 5 times 4 is 20. Okay, 5 times root 3 is not 15. You can't multiply something outside of a square root times something inside of a square root. The 5 will just go in front of the square root. That's the only way to multiply. It's the only way. Okay. Bottom. So normally we would use FOIL. However, we're not going to use FOIL because it's a conjugate pair, and there's a little trick that we can do. So watch. 4 times 4 is 16. Negative root 3 times positive root 3 is negative 3. Right. Root 3 times root 3 is 9. Square root of 9 is just 3. The insides match, so the answer is just the inside part. So final answer. 20 plus 5 root 3 all over 13. Right, 16 minus 3. B. Again, there's a number and a square root in the bottom. So I'm going to multiply by the conjugate. 3 plus root 6, top and bottom. Distributing 9 times 3, 27. 9 times root 6, just put the 9 in front. All over 3 times 3, that's 9. Negative times a positive is negative. It's just going to be 6. Right, you're going to start to see a pattern. You're going to start to see a pattern doing a bunch of these. It's just 6. So final answer, 27 plus 9 root 6 over 3. 9 minus 6 is 3. Okay. However, right now we can simplify this because this, and this are all divisible by 3. So 3 goes into 27 9 times. 3 goes into 9 3 times. And this 3 goes away. Right, 3 divided by 3 is 1. And I don't care about 1. So final answer. 9 plus 3 root 6. Okay. Simplify completely. We're going to multiply outside times outside. Actually, simplifying first would make this a lot easier because then we're not having to deal with huge numbers. So simplify, then multiply, right? The hint is kind of in the instructions. First you simplify, then you multiply. So this is 2 and 12, 2 and 6, 2 and 3. All right, 2's come out as a single 2 and multiply by the 2 that's already in front. So 2 times 2 is 4. Root 6. So the left side simplifies into 4 root 6. Right side. 2 and 25. 5 and 5. So this is going to come out and 5 is going to come out and multiply against the negative 4. So it's going to be negative 20. 2 is left inside. Okay, now we can multiply. And this is easy because it's just outside times outside. 4 times 20, negative 20. So negative 100, 2, 4, 6, 8. 80. And inside times inside. 6 times 2 is 12. Okay. 12 can simplify one last time. 2 and 6. 2 and 3. So this 2 is going to come out against the 80. So negative 160. Root leftover part 3. So here we had to simplify a couple times before, and then we check afterwards. Okay. I wonder if there's a better way. I don't think so. Okay, so here we have, what do we want to do? How do we want to do this? So first off, note there is a set of parentheses missing. Okay, outside. Is going to be 2. Inside. All right, so I was mentioning earlier, like seconds ago, if there's a better way. One thing I'm thinking, because we're multiplying the part that are inside the square root, right? We're multiplying all of this. Right, all that's being multiplied. And so it all essentially goes under the square root. So if we start simplifying now, right, and then there's 5 x's and 2 x's. So let's just do the numbers first. So here's a 7 and here's a 7. That's a pair, right? It's doubles. These 7s can come out as a single 7 and multiply against the 2, which would make 14 outside. And then left inside right now is just the 2. Okay, the x's, we have 5 x's and 2 x's. So inside we have 7 x's. So all the doubles. So here's an X, here's an X, here's an X. So 3 X's are going to come out, and 1 X is left behind. The same with the Y's. Right here we have 3 Y's. So here's a pair. That's going to come out, and then a single Y left inside. That's one way of looking at it. Okay. Simplify the imaginary numbers using the table in your notes. Okay, well, I'm just going to give you the table right now. So the table looks like this. I, -1, -I, 1. So this is for I to the first power, I to the second, I to the third, I to the fourth. This is the table, right, that it's referring to. So if you just remember that order, I, -1, -I, 1. I, -1, -I, 1. Right, it repeats. It'll never break that cycle. So this is I to the 95th power. Anytime you have any number or I to an exponent, right, I to any exponent can always be simplified down into one of these 4 figures. I, -1, -I, and 1. So the way we do that, we know it goes in 4s. So you could count 4, 8, 12, 16, 20, right? Like you could keep it going until you get to 95. Or if you divide 4 into 95, right, doing some long division. I know it's been a minute, but long division comes in clutch right now. So this is going to be 2. So 2 times 4 is 8. Subtract, you get 1. You bring down the 5. 4 goes into 5 3 times. So 3 times 4 is 12. Remainder of 3. Right? Think back to like 3rd grade when you're dividing or whatever you learn. Remainder of 3. So whatever that remainder is, that's the power of I we want to look at. So the answer to this is going to be -I. Try it again. I'll leave it up to the left. So this is going to be 107. 107 divided by 4 is 2. 2 times 2 is 8. Subtract 22. Bring down the 7. This is going to be 6, right? Because 6 times 4 is 24. Remainder 3. Again, this is the power of I from the list I want to look at. So this is going to be, again, coincidentally, -I. So here's another way. It's 107. Well, I know that 100 is divisible by 4. So 100 is really down here, right? I to the 4th power is the same as I to 100. So if this is 100, 101, 2, 3, 4, 5, 6, 7. 107 puts us at -I. 209. Let's try that again. Again, 200 is definitely divisible by 4. So we know that I to the 200th power is going to be down here. I to the 4th, right? This is I to the 200. So 201, 2, 3, 4, 5, 6, 7, 8, 9. Back at the top. So I. Right, those are the 2 ways that you can do it. That I would suggest. Otherwise, you're having to divide 209 by 4. You'll see that it's 5. Bring down the 9. 2, 8, 1. So I to the 1st power, which is just I, right? Because of the remainder. Okay. negative I to the 15th. So here, it's negative. So let's keep that in mind. But I have I, negative 1, negative I, 1. So 15. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be negative I, right? Negative I. But this is negative, negative I. Negative times negative is a positive, so it's just I. Hopefully we're all following along. Okay. Negative I to the 20th power. Well, 20 is divisible by 4, so that's going to be the bottom one. Right? 4, 8, 12, 16, 20. Right? I to the 20th is down here. So it's just 1. Answer is positive 1. But this is negative, right? Because negative is in front. So negative 1. All right, to the back. We're almost there. So we're going to simplify, again, utilizing the exact same table that we just had. So how many of these we have? Got a couple. Okay. What do we want to do first? I think the negative will come out as an I. So I times I8, we add the exponents. So that's going to be I9. I to the 9th power, right? You just add the exponents. And then square root of 49. Oh, that's 7. Right? 7 times 7. So answer is going to be 7 in front. Typically, you write the number first. I to the 9th power. Okay, I to the 9th power can be reduced down to one of the 4. So we know that this down here is I to the 4, I to the 8. So 9 would be the next one, right? Because it's recursive. It goes down, then starts over. It goes down, then starts over. So I to the 9 is up here. So it's just I. So 7 to the I. Or 7 times I, rather. 7I. To the first power. Okay. B. Square root of 4 is just 2. So we have 2 I to the 6th. Again, going to our list, we know 4 is always on the bottom. So 4, 5, 6. So negative 1. This is negative 1. So we have negative 2. That's our answer. Because negative 1 times 2. C. Negative under the square root, that comes out as an I. Right? They get multiplied. I times I is I squared. I squared, that's the easy one. That's the second one in the list. So I squared is equal to negative 1. This is equal to negative 1. Right? Because we have I, negative 1, negative I, 1. Okay. 32 can be broken down. 2 and 16, 2 and 8, 2 and 4, 2 and 2. Bring out all the pairs, and it's going to get multiplied outside. 2 times 2 is 4. So negative, right, because there's a negative 1 out. 4, root 2 left over. Negative 4, root 2. D. This is going to come out as an I. That's the only thing that's out, so that's done. This is 2 and 15. This is 3 and 5. No doubles. So they all go back in. Root 30, I. Or if you can't pull no doubles out, then can't take nothing out. Okay, negative square root of negative 98. So the negative is going to come out again as an I. So right now we have negative I in front. Okay, 98. This is 2. 40. What, 49? 2 and 49. That's nice because 49 is 7 and 7. So the 7's come out. So negative 7 root 2, because it's single, I. F. Negative under the square root comes out as an I. So negative I out front. This becomes 2, 34. 34 is 2, 17. Pair of 2's comes out as a single 2. So negative 2. We could write the I now if we wanted. Root 17. Or you could put the I in the back. It doesn't matter where the I is. If the I is in front or the I is in back, it don't matter. The I is outside. That's what truly matters. All right, G. Negative is going to come out as an I. 50 is 2 and 25. 25 is 5 and 5. Pair of 5s. That is going to come out as a single 5. So outside, negative 5, I, root, left over, 2. Okay. I feel like there's a pattern here. I like it. H. The negative comes out as an I. So outside we have negative I. Inside, start breaking this down. 2 goes to 2 and 94. 94 is 2. 47? Okay. 47 is a prime number. Can't go any more into that. So the 2 is going to come out. So negative 2i. 47 is left over. Root 47. Hope for these ones on the test. Right, because this is, these are easy. Okay, we're at the bottom. Let's go. 17. We're almost there. Foil. I feel like we already did these. This is on the front page. 7 times 5. 35. Right, foil. First outer, inner, last. That's what I'm doing. 7 times negative 8. Negative 56i. Negative 15i. And negative is a positive. 8 and 3. 24 I squared. Combining what we know, the like terms. So 35 minus 56 and 15. So 66, 71. I squared. We just learned that that's negative 1. So that's going to change the sign in front of the 24. Well, and we can combine 35 and 24. So this is going to be 35 minus 24. 15 minus 4 is 11. So 11 minus 71i. Okay, it's just keeping track of the i's and knowing that I squared is equal to negative 1. That's really it. All right, here we have 11 times 3, which is 33. 11 times negative 9, negative 99i. I times 3, 3i. This would be negative 9i squared. The last. Okay, combining what we know. 33 minus 96. Right. Negative 99 plus 3 is negative 96. I squared is negative 1, so it's going to change it to plus 9. So 33 plus 9, 42. Minus 96i. All right, this is a fun one. This one's interesting. It's a conjugate pair. Remember earlier I said, how do we multiply conjugate pairs? But let's just say you didn't remember that. This is a good demonstration right now of why. Watch. First times first is 36. Outer, negative 24i. Inner, positive 24i. Last, negative 16i squared. So this could be cancels, right? Because negative 24 plus 24. And then I squared is really negative 1. So it's going to change the sign in front. So plus 16. Right? Those 24 i's that cancel in the middle, that always happens in a conjugate pair. That's why you could kind of do what we did earlier. But let's just keep moving. So this is going to be 40, 52. Okay. We're at the end. All right. First thing, notice the 3. Right? This means we're going to look for triples. Up until now, we've been circling all the pairs, all the doubles. Right now, we're going to circle triples and bring those out as a single number. So this is going to be 125 is, I can use 5. 5 and 25. 25 is 5 and 5. So we're looking for a triple. There it is. 3 5s. That's going to come out in front as a single 5. X to the 7. So that means there's 7 X's. We want the triples. So there's 2 sets of 3s inside of 7 with 1 left over, right? You could divide 7 by 3 and get 2 remainder 1, right? So this means that X squared is coming out because 2 X's came out. And then there's already 3 Y's, so I'm going to take out all 3. There's a single Y. And left inside was the single X, the left behind X. So here, it's the same as what we've been doing on the first page, except it's triples. All right. Last question. Notice it's a 4. So this means we're looking for 4s, groups of 4s. So 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So a group of 4. There it is. There's a group of 4. All that's going to come out as a single 2. And what's outside is just a Y. So right now outside we're going to have 2. Left inside so far is a single 2. All right, 6's or X's. There's 6 X's. So I'm looking for a group of 4. So that's a single X with 2 left over. So they stay behind. Y to the 4. There's 4 Y's inside. So that's going to come out as a single y. But there's already a y in front. So they're going to multiply y squared. Uh-oh. I'm going to move this over. Okay. The reason I'm moving that over is because we have to remember we have to put a 4 right there because there was a fourth root, right? Fourth root. So you have to be complete. Okay, I think that's it. All right. Good luck. Catch you guys in the next video.